Welcome. This lecture is a brief introduction to my new book, Freedom and Evolution, with a subtitle, Hierarchy in Nature, Society, and Science. It is a broad area, too long for this short lecture. Therefore, I reduced it to the essentials, which are covered in the book, namely 4 topics. One is thermodynamics, then freedom and evolution together, diversity and hierarchy together, and science evolving itself in the direction of more and more freedom. So we start with thermodynamics, the science queen. Its laws are obeyed by everything in nature, and the basic story, in fact, the origin of the subject is the idea that power is available from heating, or power from fire. I made an icon of that. The so-called thermodynamic system is one of very many in this blue domain. And heating from fuel, or from food, if you think of animals, is converted partially into power. The remainder is necessarily dumped as heating into the environment. Now, the drawing suggests the flow of the lecture. In the blue, you have not one, but many contrivances. Some very old, some much newer. So evolution is already part of the graphics of this presentation. Now, the complete picture of power from fire is shown on this slide. The power produced in the blue domain, meaning from the conversion of heating into work, that is destroyed instantly by moving things on the surface of the earth. The moving destroyed or dissipates the power completely. So the complete picture is represented by the rectangle with a dashed boundary. There is heating coming in, and then heating being rejected to the environment. For example, the cold sky. If you think about the earth as one of the entities residing in the rectangular box. But because of the presence of flow configurations in the blue, but also in the green, there is movement driven on the surface of the earth, movement in the horizontal direction. This is an icon of everything that moves on earth: air and oceanic currents, animals and vehicles. And in other words, the entire geosphere, biosphere, social sphere is in fact projecting in front of us images that change in time in a discernible direction, meaning movies, each movie with a plot that makes sense to the human observer. The next main idea is the presence of these 2 concepts in thermodynamics. First of all, evolution literally means the changes that are occurring with a discernible direction in time. Changes in configuration. The direction is discernible in the mind of the observer. All of science is about phenomena in the mind of the observer that, of course, over time they become codified as concepts and laws and applications in the thicker and thicker books of science. Freedom is the one word for the collection of physical features that allow the entity, let's call it a thermodynamic system, to change its configuration. Without these physical features, there is no change, therefore no evolution, For that matter, no difference between now and tomorrow, which means no time and also no future. To account for this new aspect of the thermodynamics that we practice, I stated in 1996 they construct a law. I'll read it to you. For a flow system to persist in time, this is the definition of to live. It must evolve with freedom such that it provides a greater access. Let me explain. This is the physics definition of life, because in thermodynamics we already have the physics definition of death. It's called the dead state, or the being of a system where nothing moves. There's nothing, no flow, nothing changes. The boundaries are not showing deformations over time, and so on. So the life state is the antonym, if you want, or the opposite of the dead state. Important here is are the three words shown in bold letters: to live, and then to change with freedom, toward a greater access. These words really mean one and the same thing, which is freedom itself. Because without the physical features that allow changes, then there is no life, and meaning there is no movement, and also no access. I have here an example of a laboratory demonstration of the evolution in time of a river basin. From time frame to time frame, the architecture is changing, it is morphing, it is always tree-like or arborescent, but there is a direction in time which you can show through measurements. It is toward flowing more and more easily, meaning the water on this horizontal area being driven by gravity by smaller and smaller peaks of let's call it altitude. The green is really sand, originally of uniform thickness, on the floor of a laboratory. And so the movie plot from left to right is in fact the time arrow, which is brought into thermodynamics by this statement. One more thing, evolution, the concept, is as old as science itself. It comes from the Latin verb evolvere, which means to roll out, to roll forth. This word makes the mind think of the image of childbirth. Everything that is born or nascent is due, or it comes out of Mother Nature, a feminine entity. Natura in Latin means that. This is a mother word that has given birth to many other words in the language of science that we speak today. I mean the word valve, vulva, or Volvo, the brand name in the Swedish automobile. All these words have the same origin as evolution itself. Now, with this law of physics, many researchers today have shown that it is possible to predict not only the evolutionary designs that have been observed and documented, but also to predict the future of these designs over time. This is a panel of the designs that endow all sorts of systems on Earth with locomotion, that is, movement driven by power, swimmers, runners, and flyers. You have here a surprising agreement between the observed speeds of locomotion versus body sizes. The body sizes cover a huge territory from the housefly to the biggest ships. This unification of movers on Earth is a drawing coming from me that has been evolving over time. The ships are the most recent addition. They show basically agreement with the swimmers. The airplanes, they appear to be deviating from the line of the flyers. More recently, they've been brought in line with the flyers, with the animal flyers, by taking into account the fact that the density of the medium in which the fastest airplanes are traveling is sensibly lower than the density of the atmosphere against which animal flight is designed. And so this success, which is the agreement between all these dots and the theoretical lines shown here as two parallel lines for flyers and swimmers, this success is accompanied by a cloud-like distribution of data, a diversity, if you will. Very soon you will see a blow-up of this region of the fastest movers versus the body sizes. And that is how the next idea comes on the screen. The cloud itself is about diversity hand in hand with the predictable trend. And this is a blow-up of that right-hand extremity of the previous drawing. We have the body sizes, we have the speeds, and here you see in each of these groups, flyers, runners, and swimmers, they're the fastest. The fastest are not the biggest. The biggest animals are somewhat slower than their fastest, relatives. And this hump has been used by many as an argument that the general trend is incorrect, and the slogan of that particular point of view is that the biggest are not the fastest. It turns out that, in fact, the biggest are the fastest. What we have here as coming from zoology are the maximum speeds. And of course, the maximum speeds of animals have to do with the lifestyle of the animals. So the fastest animals, flyer, runner, or swimmer, are in fact the predators. The really big animals that are fast are not the fastest are the grazers, the ones that move all the time and of course eat all the time. So the speed average over the lifetime of the mover turns out to be in accord with the prediction that the trend is toward greater speeds, average speeds, as the body size increases. You can see this very clearly if you think about the evolution of airplanes. We have big commercial jetliners that are fast, but not the fastest, yet they fly all the time. They spend their lives almost entirely flying, compared with the lives of fighter jets. Well, the jet fighters are spending most of their time hidden in hangars underground. So, in other words, just like the cheetah is mostly at rest. The lion is mostly asleep. The house cat is mostly asleep. Yes, all of them are fast, just like the sprinter in the 100-meter dash when the feeding time comes. there is a diversity everywhere. No one would confuse the hummingbird with the albatross, or the house cat with the lion. And this diversity has its own physics, meaning physics. If you know it, then with that you can predict the diversity. You get that idea if you make drawings the way I do. I make them all the same size, you see. And so comparing the cat with the lion, we notice here that the cat is mostly belly, small legs. The lion is showing more legs as opposed to belly, and the elephant is even more exaggerated in the direction of greater legs. It turns out that with physics and of course the mechanics of the lifting organ, which is in this case the legs or the wings here, or the undulating tail in the case of the swimmer, the mechanics of this periodically flexing lifting organism calls for this relationship between the body fraction occupied by the lifting organ in the entire size of the mover. The kind of comparison and aha that I showed here for animal movers is available also for us, the many specimens of the Homo sapiens. If you look closely, in fact, this is well documented. The body configuration of the West African type, which is on the left, is slightly different than the configuration of the European body on the right-hand side. The main difference, the first one that I brought to light in my work with this constructive law, is that the center of mass of the West African type is slightly higher than the center of mass of the European type. This, 10 years ago, I showed was responsible for the uniform success or dominance, if you will, of the West African athlete in sprint versus the total dominance of the European body type in the sprint in water, meaning swimming. The interesting conclusion with regard to the diversity that's apparent if we look at the human population on the globe today is to ask what happened in between from left to right. Well, obviously, there must have been mixing or interbreeding with another type that had the effect of lowering the center of mass of the result. And that interbreeding happened in the history of migration of Homo sapiens out of Africa. It started the first migration was 1.5 million years ago. It coincided with the adoption of fire. Pay attention, a big move in the empowerment of the Homo sapiens gave a green light to stepwise greater migration on the globe. The first migration was followed by the second, which coincided with the adoption of clothing. At that time, Homo sapiens moved out of Africa in the direction north and east, meaning the Middle East. Other hominids, such as the Neanderthals and the Denisovans, moved in the same direction and spread all over the Middle East and Europe and Asia. And then, with the advent of boating, another big jolt toward easier movement on the globe, there was the first interbreeding between the Homo sapiens and the Neanderthals that generated a new population of Melanesians and Australoids. And then a second interbreeding happened between the Melanesians and the Neanderthal as well. And then finally, 30,000 years ago, the third interbreeding between the European type and the Neanderthal, which led to the East Asian type. This is how the modern humans exit this particular slide to the right and enter the kind of history that with which we are most familiar. And most of the history of humanity is about the past past 10,000 years. You have here all the breakthroughs in technology, science, transportation. Up on top, the explorers who are famous for having spread people all over the globe, and the four types, how they evolved from left to right by continuing this interbreeding tendency. And today, again, we're exiting the screen to the right. We are, in fact, many, let's call us types or individual specimens of the one species that I call the human and machine species. This is the reality shown here graphically with the image of naked man, then naked man with a nature-inspired tool, and these days naked man with the tool and with the next or future tool generated by the human mind. This is the, let's say, the add-on due to artificial intelligence. The important observation to make here is that in evolution, what works is kept. The wrench did not make the naked hand obsolete. Let's call it the intelligent arm will never make the plumber's wrench obsolete. You see? So in evolution, what works is kept. The diversity of the human and machine species is even more evident if we look at what each of us carries in our brain. This is a graphic of how that evolution has happened in the domain of engineering science. The past 300 years, or mostly 200 years, what used to be mechanics, mechanisms dating back to antiquity, became important and also companions of newer ideas called civil engineering, mechanical engineering, electrical, chemical, and so forth. And along the way, during this movie of the empowerment of the human and machine specimen, what worked was kept. Electrical engineering obviously did not eliminate mechanical. These new ideas work hand in glove with everything else that preceded them as good ideas. The diversity that I just illustrated is not random. It is organized into hierarchies. We get this next idea by looking at, frankly, anything that means population on the globe today. Here's the population of models of airplanes versus on the abscissa their year when each model was adopted. On the ordinate is the size of the flying body. Obviously, this is a hill or a mountain, the crest of which is rising over time. The biggest models are joined, say, a decade later by even bigger models. But that's the trivial observation. The subtle is that at any particular time during one given decade, the new models are arriving in all sizes, small and large. And even more subtle is that the new models that arrive are such that the small are many. They're all new. Small are many, and the big are few. And that is called hierarchy. It's more evident if we look at all the flyers beginning with the birds and of course pterodactyl. The point is that in a two-dimensional plot of population size versus body size, qualitatively, there is a straight line on a logarithmic plot, a descending line from the many small to the few large. In other words, design in nature, the organization of flow systems happens, it just happens in this way, hierarchically, not in one size. And why? Why is this? Once again, because of physics. And the answer comes as a kind of a two-punch move in a boxing match. The first punch is economies of scale. You can show with pencil and paper as a homework problem that a stream of water that flows, one stream of water that flows through two parallel pipes of equal size, flows a lot more easily through a single pipe that's more voluminous, a single pipe that has the same volume as the original two pipes. In other words, the change in flow configuration toward flowing more easily is from 2 to 1. That's economies of scale. You can write the equivalent problem by thinking of two small bodies, two barges on a river being pulled against drag. The barges are loaded with coal versus a single barge that's bigger, carrying the total load of the first two. You can show that the power required to drag the big one is considerably smaller than the power required to drag the previous two. So the change toward easier flowing from physics is from 2 to 1. And if this is the tendency in nature to flow more easily, then why is it, or why was it, that not everything that's moving on the landscape is big? The reason is that the flow on the landscape is not from one point to another point, as in, the simplest problems of geometry. It is between one point and an area. The direction of the flow doesn't matter. It is because it's about the fact that the point is one and the area means an infinity of points, or between a point and another infinity of points called volume. And for the flow to cover the infinity of points, well, that flow must have access to smaller and smaller and smaller pockets of territory between the bigger territories that have been served, were wetted, were swept by the big movers anticipated or recommended by economies of scale. So we arrive in this way at hierarchy. Another word for hierarchy, or the natural emergence of hierarchy, is called organization, or coalescence of living things or movers. You see that in this photograph that I took two photographs. Seagulls on the roof of a cottage on the seashore, facing the breeze. They do two things. Actually, the three things. First, they come together. Second, they face the wind the same way. Third, they space themselves such that the ones in the wake have the same spacing as the vortices of the Karman vortex street, meaning that each of the trailing birds is feeling a relative push from behind, from the wind that swept downstream, and that push from behind makes the trailing bird a lazier worker in its legs, meaning it has to do less work to stand up straight in the wind. Here, the upper photograph is about cranes, the way that they are oriented when not working, oriented in a strong breeze. The front of the crane is this one, the one loaded with a weight, meaning the beak of the crane bird is on the left, just as it was in the lower photograph. This hierarchy or organization is on display everywhere. The movement of people on an area such as the Atlanta airport, few large and many small. The one large is the train. The many small are the pedestrians on the concourses. This drawing, Atlanta airport is an icon of the natural emergence of the city block, with walking perpendicularly to the smallest alley. Freight on a larger area moves the same way. The same freight is being vehicled on the area by few large trucks and many smaller trucks proceeding transversely. The so-called food chain is really the coexistence of few large movers with very many movers that cover the area in the other direction. And the biggest example of this type of hierarchy emerging naturally on Earth is the movement of humanity on the globe. This is the air travel 20 years ago, illustrated by NASA in terms of the measured condensation trails behind all flying aircraft. You see where the flying is going on. That is where the red is the heart with the two chambers of air travel. The whole globe is traveling, and so the movement is hierarchical, and that means that the fuel consumption is hierarchical as well. This hierarchy was not dictated by the General Secretary of the Communist Party. This happened naturally, and with that idea, we can now admire another version of the facts. Plotted here are facts about economics, hand in hand with the technology of driving movement on the planet. Fuel is being burnt, of course. From fire comes power, from power comes movement, and you see here that annual fuel use is essentially proportional to annual wealth, known as gross domestic product. And so the conclusion then is that there is a rough one-to-one proportionality between annual fuel use and annual wealth. We've already established that fuel use emerges hierarchically naturally. That means that the hierarchical distribution of wealth on the globe is hierarchical, is natural as well. So the natural phenomenon that gave birth to hierarchy in air travel is the same physics that makes wealth hierarchy unstoppable, if you will, on the globe. The subtle point about this graph is the time arrow of all the dots that occupy this yellow band. All the dots are racing upward. Listen to government reports every year. Doesn't matter which country you're concerned with. Governments are interested in greater wealth or increased GDP for their population. And that means, of course, necessarily an increase from year to year in fuel consumption. So there's a time arrow, which is as old as the Homo sapiens. In this case, this panel is about the evolution from the adoption of fire to power generation today. I made it in 2 dimensions to show how the acquisition of fuel for heating proceeded through social organization, from hunting and gathering to all the way to the present era. On the abscissa, the same story, but in the language of social organization, from band to tribe, all the way to state and global constructs today. The time arrow is toward increase in population, advancement, wealth, freedom, and of course, in the same direction, science itself is evolving. The population is increasing. The individuals, of course, become more and more numerous. They become less and less visible. And unfortunately, the single individual in this direction becomes less and less important. And that brings me to the concluding idea, which is that the science as a construct of the human mind, an empowering construct, is itself a evolutionary design, evolving in this direction of time that I just illustrated. I have a way to illustrate that with the evolution of thermodynamics itself over the past 200 years, from its origins, originally caloric theory and mechanics, and then 150 years ago, thermodynamics. Almost 60 years ago, the corralling of the long lost child of caloric theory called heat transfer back into thermodynamics, and then today, meaning something like 20 years ago, bringing in the evolutionary designs, the designs that in fact are responsible for the thickness of every single thermodynamics book. Every thermodynamics book is about contrivances that have been getting better over time, techniques for producing power from fire or producing heating and cooling from the same fire. Those drawings are in the books. Well, they've been evolving. They've been evolving over time. And now with these 3 roots into the very fertile ground of human ingenuity, we have a thermodynamics that's I think much better position to advance forward. Now, there's a subtle story that goes with the movie that this drawing is like the poster for a movie, and it is that the march from left to right is punctuated by individuals. Individuals had ideas. You see their names in the better books that have been written. You see the places where they produced, Renaissance in Italy, or obviously steam engine makers in Britain, and you know the examples. These are very special places. These were places where the individuals were not only free enough to move and to talk and to speak, also wealthy enough to move, to talk and to speak and to write and to publish. But these are places where individuals were encouraged to come up with ideas. And so from left to right, the evolution of science is speaking of the importance of freedom in the march toward performance of any evolutionary design. My concluding slide is of the opposite kind, which is this doesn't require any explanation, except that the punchline is that march in columns, do not climb peaks. With that, I thank you for your attention. Once again, on the left-hand side, I summarize the main words of this presentation. These are words that traditionally are not spoken in physics. They are not spoken in thermodynamics. My argument is that they should be spoken, and the speaker should be encouraged to come up with even better ways of speaking. Thank you.